Hey guys, okay, so over the next few days we will be making a couple of videos for regarding the CBSE topics for science and maths. Now these videos are meant for people who don't particularly listen in class, and I urge you all to not use this as your study material. Just use this as your reference material for the exams. By the way, this is for the third term only. Hey guys, okay, so for today we'll be doing chapter 10, that's light, reflection and refraction. Okay, so I'm going to start off with something simple. That's the types of mirrors you have. That's you have a plane mirror, concave and convex. Now in this chapter we'll be focusing on concave and convex mirrors along with their respective lenses. So first of all, what is a concave mirror? Alright, so this particular thing right here, actually no, I'm going to draw a really easy one. Just draw a circle and okay, here you go. Alright, this should be good enough. Alright, so now you have this is your concave mirror, and now basically what does a mirror do? Well, you can say it, actually no, you can't say it actually does. All it does is it reflects the light back to you. Now depending on the type of mirror, being plane, concave or convex, you have different images that are formed and different places of the images. So first let's go into the different structure of the different components of the concave mirror, actually of any mirror at that, like concave and convex. So firstly you have this particular portion is P. This is the pole, this is half, this is the center of your concave mirror. Alright, so now every mirror is actually part of a circle. You can say, I'm just going to draw a rough circle over here. Okay, this is a very horrible circle, but anyways, you understand the point. It goes a little like here, and then it goes. This does not exactly look like a circle, but whatever. Now this particular part, the center of the circle that was used to form the concave mirror, is called the center of curvature. That's, let's say, around here. Now half of the distance from the center of the curvature, which is depicted by C, to the pole, that is called F, of focal length. F, it's depicted by F. Alright, so what else is left? Next you have your principal axis. That's basically, you take an imaginary line, that's this line right here, this particular line that I drew, that passes through the pole of the mirror. That part is called your principal axis. Alright, so I just said that you have a focal length that is equal to half of the distance between the center of curvature to the radius, to the pole, but you can call it radius. So basically you have F is equal to R by 2, because focal length is equal to half of the radius, so it's basically R into 1 by 2, so that's R by 2. Alright, or you can just say like R is equal to 2F. It's also what you can write, it's totally up to you. Okay, so how about we move into properties of concave mirrors. Well, concave mirrors, they basically give you a sort of how to say, they give you a magnified image of yourself, of whatever image is formed. Actually not magnified, but like point size, and yeah, kind of magnified. So now we have I'm going to draw the circle again, the concave mirror again. 1 minute. Alright, so first of all, before going on to the properties, I will quickly show you what happens when the image comes from infinity. That's like this. Basically what happens is it just, oh no, sorry, it goes about like this. Actually no, it goes about here. Yeah, this, if it comes from infinity being like this, that's how you kind of depict infinity, but whatever. The image, it's actually formed on the focal length. And actually no, this part is called the focus. I am really sorry, the length is called the focal length, but this particular part is called the focus. And now the image is actually formed on the focus, and generally this would be a point sized image, assuming it's coming from the from infinity. Now how about we move a little bit closer? So say instead of infinity, I'm just going to shorten this real quick. Yeah, okay, fine. So this is our image. Now this right here. Alright. So now say the light is actually coming from like before C, not at infinity. So I just have to draw this real quick just to show you. Okay, fine. That's like this. Principal focus continues over here. Alright. So now say this is your object. Say the object is standing before beyond the center of curvature. So basically, where do you think the image would be formed? Well, it would be formed somewhere around here. Well, actually it depends on the height and all that of the image, but you can say it's formed over here only, between C and F. Okay, and next we go on to, if the what do you say, if the object is at C itself. If the object is at C, the image would actually just form, or the image would be formed at the center of curvature. Okay, and now say you have this. Now the image is actually between the focus and the center of curvature. So in that case, it would be beyond C. Okay, and finally, when the when the image is actually at, oh no, sorry, yeah, when the image is at F, that's a focus, the image would be formed at infinity. This very far, like this, and dot whatever. Okay, alright, so now that we've gone through the properties of concave mirrors, how about we go into the convex mirrors? Okay, so here I have the image, the convex mirror, and now say you have an object standing at infinity. Well, I'm going to bring this a little bit closer. Okay, so you have this. Now it's a convex mirror, right? So basically it should reflect the light like this. So basically you would get a very enlarged image over here, and the image would actually be formed at the back. Oh, what did I just do? No, okay, sorry guys, sorry. Anyways, as I was saying, yeah, okay, there you go. Now the image would actually be formed behind the mirror. That would be somewhere around the focus. Actually, it should be around the focus. Alright, the image would actually be formed behind the mirror at the focus. Like say when I said the concave mirror, it would be formed at the focus from infinity. Same thing over here, but this part is considered the back of the mirror. Even though the mirror is shaped like this, this is always considered the back of the mirror, and this is always considered the front, no matter what. So next we'll move on to some sign conventions, you can say, of the actually no, wait, no, we have a couple of rules to go over for this. 1 minute. Okay guys, so here I have 4 images. Now I'm going to only draw for the concave mirror. I'm going to draw the illustration for only the concave mirror. However, if it's a convex mirror, just all you have to do is, like, if you have the reflection over here, just draw the line and draw a small dot all the way till here, all the way to whatever, like focus or anything. I'll tell you according to law you have to draw this. Alright, so first law states that a ray parallel to the principal axis will the reflected ray will pass through the principal focus, that is basically F, or in the case of a convex mirror, it will appear to diverge from the principal focus. So if it's a convex mirror, basically you would end up with something like this. It goes upwards and you have your dot, and let's say, assuming this particular part is F. Okay, so anyways, that's the first law. Now second law is basically the reciprocal of the first. It's quite simple. A ray passing through F will principal focus will emerge parallel to your principal axis. Now in the case of a convex mirror, you can draw the ray about here on top, and you can draw the ray about here on top, and then it will reflect, and this particular part should meet at F. Because like I said, it passes through F. Alright, next we go on to the third law, that is, if a ray passes through the center of curvature, it is deflected in the same along the same trajectory. So basically, if you have a ray coming like this, it will just get reflected along the same line, like it'll go like this. Okay, and finally, oh yeah, by the way, you can even show this even in a convex mirror by showing a line like this. Now this part, the dot has to actually land on the center of curvature of the convex mirror. Okay, so finally you have, if a ray passes through the pole of the concave mirror, it is deflected at an angle. That's it. That's your laws. Alright, so here I have a simple concave mirror. Now firstly, one basic rule is you have to always take the convention is always from left to right. You don't take it like this. I do not know why it's just like that. Right, and next you have your height. Now this you don't really need to explain much in this. It's height. If it's positive, means it's above the principal focus. Principal axis, it's positive. And if it's below the principal focus, principal axis, then it's negative. Alright, so now any distance, the distance from the concave mirror or the convex mirror to this particular portion, that's like this distance right here is negative, always negative. And from here, if you have the image over here or the object over here, it'll be positive. This is actually for both convex and concave mirror. I'll just quickly write down the certain conventions as they are mentioned in the textbook. Feel free to pause the video and have a quick look at it. So guys, how about we go into magnification? Well, you all know what magnification is. Magnification, yes, it's basically enlarging of an object, but then you have your negative magnification. That's a whole other story. But anyways, you have a simple formula that's m is equal to h dash. The h dash is h like that, h by h. Now what h dash is, what h is basically the height of the object, while h dash is the height of the image. Perfect. Okay, so now you have m is equal to h dash by h. Now we learned just recently, maybe 30 seconds ago or something, we have the object distance, that is u, and image distance, that is v. So we can also say that h dash by h is equal to negative v by u. Am I right? Yes, I am right. Perfect. If h is positive, you basically have a virtual image. So basically you can just simply write positive h is equal to virtual image. This will actually be quite important when you're given a question to say find the nature of the image or find magnification, all that. And negative h will be used for this real images. So basically if you have negative h, that's negative height of the object, you got a real image right there. And finally you have for magnification. Magnification is pretty much the same thing. You have negative m, which is equal to real image, and you have positive m, which is equal to virtual image. Alright, and with that we are done with lenses. Woohoo! Actually no, we're done with mirrors. My bad, sorry. Now how about we go into refraction of light. Now there's a big difference between what refraction and what reflection is. You have, say, a light is coming like this. Okay, now you have a mirror over here. This mirror will reflect the light back, or here, whatever. Okay, and now say if you have a lens we'll do in a short while. I'm really sorry if this is poor, I have to get a little bit better. Okay, so now if you have a lens, this will actually refract the light. That means bending of the light. Now reflection is deflecting of the light, that means bouncing back of the light, and refraction is bending of the light. Now what actually causes this? Well, basically it is caused due to the fact that the light is passing through a transparent medium, actually two transparent mediums with varying densities. Now for example, you have a glass slab. That's basically a rectangle. I'm going to show you only in a 2D form. I'll just make this a little bit thinner. There you go, better. Alright, so now you have a light. The light source enters in like this. Okay, to make things easy, I'll just draw this like this. And now you'd expect it to come out like this, right? Is this right? Yes, it's right. Okay, now you'd expect it to come out like this, right? But no, that's not what happens. It actually refracts over here and comes out. Actually it refracts somewhere here like this, and here it would come out. So it would come out over here, but these two rays would always be perpendicular. That's quite given, actually. It's quite understood. I'll just draw the dot. Yeah, that's it. Actually no, a little bit better. There you go, dot. Okay, now if you watched my previous video on, I believe, the human eye, I would have mentioned what the different angles are. Now you can refer back to that video, but I will explain it a little bit over here. Now you have angle of refraction, that's basically the angle that's over here. Angle of emergence, that's the angle over here. And angle of incidence, that's it. So anyways, now you have a glass slab, and oh yeah, if you don't know about this, a glass slab is basically two prisms. Now if you think about it, I have to draw another glass. Now I have to actually draw a 3D glass slab. As I was saying, if you were to think about it, a glass slab, if you were to cut it into half, what do you think would come? This is one extremely fat glass slab, I realize that, but anyways, it's easier to explain. Now if you were to cut this glass slab from here all the way till, I think, here. Yes, I hope that's correct. Yeah, all the way till here, you would basically get two prisms. Now this is exactly why you have a white light which passes through it and comes out as a white light itself, not as a rainbow. If you were to say have a prism only over there, a single prism, you would get rainbow, a set of colors, that's rainbow colors basically. However, in a glass slab, it's basically two prisms inverted, so the light ray would come like this, it would become the various colors, and then over here the other prism is there, so it comes back out like this. Actually it comes at this angle because these two usually should be perpendicular. This line and this line should be perpendicular mostly. Okay, so now that's all good stuff. Now how about we move on to lenses. Now lenses are pretty basic, pretty simple things. Oh yeah, oh my god, I can't believe I actually forgot this. You have a refractive index. Now refractive index is very simple. It's basically the extent of the refraction. That's basically how far the light would actually refract inside the medium, inside the second medium to be more precise. Okay, so this is also, yeah, that's it. Now we'll actually move on to lenses. Alright guys, so here I have your converging lens and diverging lens. Now basically this right here is actually called a convex lens, and this right here is called a concave lens. Okay, now one easy way to remember this is by noticing just the left part of your mirror. Same way over here, left part of your mirror. Okay, so over here basically the left part is concave mirror. So when you make, so basically you have a concave CV lens. Similarly over here you have convex mirror over here, so you have a convex, oh no wait, you have a CC over here, sorry, convex lens. Okay guys, I'm really sorry, but since we don't have much time, please look at the image formed on a concave and convex lens at the textbook. Just look at the small table you have in the textbook. And now we'll go on to magnification of lenses and the formula as well. Yeah, you remember you had that V by 1 by V minus 1 plus 1 by U is equal to 1 by F. Well, for lenses it's basically 1 by V minus 1 by U is equal to 1 by F. And magnification is actually pretty much the same over here, except for one minor thing over here. Magnification is equal to h dash by h, which is equal to negative V by U. However, for lenses it's positive V by U. And yes, that's about it. Next we'll go on to power of lenses, which is our last topic for the video, and then I will be done. Okay, so basically power can be defined as the reciprocal of the focal length. So yeah, that's actually it. P is equal to 1 by F. P is equal to 1 by F. And now for every where F is actually in meters. Okay, now one power is equal to 1 diopter. 1 diopter, I hope I spelled it right. I wrote doctor. It's diopter. And now 1 diopter is equal to 1 meter. So anyways, power is basically just 1 divided by the focal length, or the reciprocal of the focal length in meters. And yes, that's about it. Now if you've been listening, you should have understood what a convex and concave mirror are, then the different images, the different locations where the images are formed on both of the mirrors, what is a refractive index, then what is magnification, then what's the sign convention for this for concave and convex lenses, mirrors, and then what refraction of light is, and finally lenses. What lenses are, the different types of lenses, and power of a lens. How is it defined?